Hey everyone, welcome to the end of the week. Finally I get a chance to get some boards done. Hey, Let Us Repair, Quartos, Jedi, Thomas. Alright, what have we got? Oh, this is not a 1990 or a 2141. This is actually a 1707. So that's something different. So I can actually plug this in and see what's going on. And that would be really spectacular if my software was working. Why aren't you working, software? Clearly it's a... Seriously? Nothing's working. Well, nothing's working because nothing... Oh, maybe it is actually. No, I'm just wondering whether, in fact, there's nothing wrong with the machine, and it's just that... I mean, there's nothing wrong with the USB meter, but rather the machine is actually not doing anything. Yeah, it's the machine. Okay. So, that's interesting. Is it on all ports? Okay, that was weird. 3 amps. So we've probably got a problem down here. 3 amps off the 5 volts before it even negotiates to 20 kind of tells you that you've got a bit of a problem somewhere near your CD3215s. Alright. Hey Pedro. Hey Jim. PR, Mycosis, Stuart, Janos. It's been a busy week this week in the yard. A lot of running down to the dump, throwing into the dump, lots of dumpy stuff. Lots of shrubs cut back, weeds pulled out, all sorts of stuff. Okay. Zero effect, probably not a good topic to bring up for me. I'm a little bit hostile about that right now. Yeah. I mean, I didn't do anything with the PlayStation stuff, but I have my other points of contention that I'm a little bit hostile about. Anyway, that's the way it goes, the way the cookie crumbles sometimes. Hey Cypher Labs, we only just started. Yeah, there you go. See, Pedro just told you don't mention the 5K. Yeah, sometimes you feel like you do a tremendous amount for the community and somehow it kind of doesn't directly get rewarded. I mean, okay, I now do commercial software in order to self-reward. Now, I suppose that's what it comes down to, is in the end I thought, you know what, the chance of someone waving a magic wand and I all of a sudden get my golden carriage or whatever is 0 to none. And look, let's be honest, 5,000 is not going to get you very far in life. It's a nice little weekend deposit, but it's not a big, it's by no means a big sum of money. So yeah, I mean, I went commercial and did Flexboard View. But there's still a few little discontentments. I mean, I've been doing open source since the late 90s, mid to late 90s. I can tell you right now, it is not a very, it's not a very good way of having a dependable income. Not that you would expect it to be. I mean, that's the other thing, is I think a lot of people, they will do open source because they're deluding themselves that they're being altruistic, but concurrently expecting that someone's going to cough up a bunch of money for them for being nice. And then they get all jaded and everything like that. Wait, this is starting to sound like me. Yeah. They get all jaded when they don't get any money, or other businesses, say, use their software legally and package it into a commercial offering. And yeah, it's you see it a lot. Yeah, I'm sure Phil's going to enjoy that 5,000. I don't know, yeah, whatever he does with that. I have, look, in all honesty, I have actually received 5,000 in the past from Lewis for when we were getting open board data underway, and I had to design the keypads and things like that. The difference there is that the bulk of that money didn't even go to me. The bulk of the money went to producing those circuit boards and their multimeters and sending them out. And I got a small portion, but certainly not a major portion. And it reminds me of the situation recently where my wife did well, not recently, it's about 10 years ago now. She wrote a book, and then the local play group wanted it to become a playwright. And so she received a grant from the arts foundations or whatever to produce this. However, the amount of money that we received to use was basically zero, because we had to make sure that all that grant money actually went to other people. And that's often what happens, is you can be given a lump of money, but you have to actually distribute it to other people. You don't get to keep any of that money. So when people see or hear that you've received a grant for $5,000, they immediately think, oh, well, you just got that and that's yours to do what you want with. But the reality is, there's more often than not, there's stipulations, and you have to spend that in certain locations, of which you yourself basically do not get a cent of. So yeah, that's one of the hilarious sort of things that happens in life. Hey Dan, Console Hospital. Alright, that's a pretty messed up 1707. Now, usually the 1707, the left-hand side always gets environmental corrosion. This one looks no different, but our primary fault seems to be over on the right-hand side. Someone's already been here. You can see because the sticker's removed. Put the extractor on. Hey, John Samuels from Rome. Just getting rid of all the trashy dust. I suppose at the end of the day, that is why I took matters into my own hands and I went commercial with Flexboard View. Because at least if you're dealing with it yourself, you've only got yourself to blame if it succeeds or fails. And yeah, buzz. Well, there's certainly a lot of suspects down there. Have I got the right side? Yeah, I have, yep. Now, the big problem with dealing with these type of machines, 1707, 1706, etc., is that they are of the age where you're going to fix up one thing and then 3 weeks later something else could well die. So you're going to need to be careful when you repair these, that you stipulate that you're only going to warrant what you've actually done. I mean, you should normally only warrant what you've done for the most part, but even more so with these machines. Milo, is that you? Come on, man. I got a feeling someone's been in here before. See these scratch marks here? They're not from my toothbrush. Someone else has been here. This machine has been repaired prior. Oh yeah, definitely been. Look at all the scratches there. Gee whiz. And you've got corrosion there. A chain stuff, ATO soup, Sihege. We've got to find that short. I'm hoping it's not a 3215, but it could well be. Mind you, yeah, you know what, I don't know. Maybe I should just simply... I should really just put the, what do you call it, thermal camera down and spot it. I mean, 15 watts of heater going in there somewhere. So it's not going to be subtle. Let's just use the infrared camera. Come on, we're doing this as a job. Yeah, we're doing this as a job, not as a tutorial or anything like that, so let's just get on with it. Hey, slime. Well, that's something just down here. I think that's intense enough that we should be able to find that with just some, what do you call it? Isopropyl. The magic pings. Who's messaging me? Oh, Mr. Anderson. Mr. Anderson has contributed 50 Australian dollars through PayPal. Welcome back, Mr. Anderson. We missed you. It's going to be one of these caps, is my guess. All right, who wants to take a guess which cap it is? So let's see. So we got 1, 2, and 3. I'm pretty sure it's one of those 3. Dan, very sorry to hear about that with your 15-year-old boy. So we've got a 3 and we've got a 2. Alrighty, yeah, I'm not sure. I'm not sure. Not even. I've got the microscope view and I still don't even know. Okay, bets are in. So we'll load it up. You watch, it's not even going to be any of them. Oh, yeah, it kind of helps if I power it up. Here we go. More alcohol required. Oh, it's the MOSFET. Which means there's probably a short elsewhere. Well, that's no fun at all. Okay, interesting. So the MOSFET shorted. Well, actually, you know what? The MOSFET may not be shorted. It might just simply be that, kind of like with iPhones, it just simply is the indicator that there is a short somewhere. And we've got to follow it. 281. So it's not going to be a simple one. Okay. Could be interesting though that it's the only one that complains. Alright, we're going to do some checks. A front sauce? Yeah, I'm not really sure about suggesting on that glue stuff you're talking about. I know what you're after, but okay, so PPDC in seems to have a problem. I'd say we just take that MOSFET off and see if we can isolate the issue. Oh, where the heck are my tweezers? I don't know how it is I lose my tweezers. Trouble is, David, right now the MOSFET cooks up, so we don't really know what we're really chasing until we get this MOSFET out of the way. It may be the MOSFET itself. It is possible. Let's see if we still have our short or not. We do. Alright, injection time. This is really not the normal pathway that I take for repairs, but looks like we're taking this path. Hopefully it's a path I can follow any. Might be being a little bit unrealistic here. Someone mentioned short killer. Oh, I know. You guys are taunting me when you say that. Shudder to think how many repairable machines have been lost due to short killers. And we're going to go 1 volt, 1 amp. Start on that, nice and easy. Hello, Trorep. Good evening. A Weasel box. Now, as far as I can tell, we've got about a 3 ohm short on there, so 1 volt, you might see 300 milliamps. So there we go. We've got 350 milliwatts of heat coming out. That's enough. Assuming it's going into a single shorted cap or something like that, then 300 milliwatts should be enough for us to find it. You can see the heat from the hot air that we were doing. Doesn't take much, especially that this camera can be very sensitive. Okay, 300 milliwatts. That there is just a shiny part. Hello. All the way to the other side of the board. That's hilarious. That's the other MOSFET. All right. Okay, looks like we're going to look at the other side again. Where all the corrosion happens. Okay, so it was where they had been scratching around. Scratch around. What were they? They must have been using fiberglass pen or something. That's really nasty stuff there. Nasty hobbitses. I think they've done something with that. In fact, that 3215, you can tell by the sheen, I think is bubbled up. I think that's got a bubble on it. And if it hasn't, it's sure it looks like it. Could be just the polish. Let's see. Ow, 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 ow. Oh, it's definitely got corrosion all over it. Someone's done something with that. Sand down the bowl. Sounds good. So I think I'm going to have to pull this one. There shouldn't be flux oozing out from underneath it. I'd say there was a lot of liquid damage under here and they didn't clear it. They just scrubbed around. Yeah, You can tell by the way that's come off that that was an absolutely dreadful replacement. I kind of wonder whether that's damaged or not. let's go back to the purity of the original short and see if it's still there. It's gone. Yeah, so it was a 3215. Look at that. That was just a terrible, terrible, horrible, rotten, dreadful replacement. I wonder if it's actually that cap. Oh, cap's good. Okay. It was a CD32. Come on, heat up. Oh, where's my wick? This is why you don't use $50 eBay special repair. Because $50 eBay special repair means they will scrub it like that. They go, oh, it's corrosion, let's just scrub it away. And if you're unlucky and it boots, they're going to send it back to you along with the bill, with nothing actually fixed. Yeah, that cap is moving around. Did I knock a part off from there? I'll have to check the board view. But all this... Wow, what? Okay, they must have used low melt solder or something, like something with bismuth in it or whatever, because that has stayed molten far too long. So yeah, I think they've used low melt, which is why basically nothing is sticking properly. If you must use low melt, be sure to remove all traces of that low melt before you proceed to put things back together. Okay, low melt can be a helper, but it can also be a great damager. Anyway, I personally do not use low melt solder. I think normal leaded is ample enough. There's not too many circumstances where you really have to use that low melt stuff. I mean, fine, if people are comfortable with doing that and they can, you know, stick to the cleanup protocol, no worries. That's on them. But for me, I don't yet encounter the situations required, you know, demanding its use. I'm 99% sure there's probably a missing part there too. Oh, no stuff on that one. Interesting. Okay. Thanks for that, Craig. Alright, so we need a 3215 and we need a cap. Low melt for display FPC connectors that melt. Such as... I do the displays without low melt display connectors. You're talking about a different kind of machine? What's it? Schematics. Let's see. 1063402. Okay. Oh, that is not what I want. A few thousand capacitors just flew out of the box onto the floor. Fortunately, 99% of them are bagged up, but still not what you want happening. Okay. Hey, where the hell's my 10 microfarads? Ah, bandages. I really need to fix these tweezers up. Take a slight interlude to fix these up. Terrible. Might just have to draw only. I'll do. I'll do. Yep, good old shift time. What did I do with the cap? Oh, I think I found it. What grit is it? I'm not sure. It's just, as far as I know, they're just normal fishing hook sharpeners. At least that's where I used to get them. You go down to the local fishing shop, and yeah, they use them for sharpening hooks. Oh, let me guess, I've got no 3215s. Alright, this is going to be fun. I'm very sure I do not have any 3215s left. I might have to extract and reball. What do you got, Mr. Daniels? You got nothing good. Hey, Tony Nash. Oh, what are these? Oh, might have actually one after all. Freshly reballed. Genuine new reball. But you're right, I might have to start chicken winging them. Let's see. Now the only trouble is, of course, I don't know whether they've used leaded or lead-free. So we're just going to have to take it easy. Yeah, I'm going to guess that was leaded based on the fact that it... Hey, Murta? Yeah, 100% tested. Yeah, that seems like it went alright. The big problem here with this board is that I genuinely feel like even after it's repaired, it does have enough damage on it that it could well just die in another couple of weeks anyway. Flux. Get ourselves a replacement. I'm not going to reuse the one that I took off just in case. It's... yeah. Let's see. Oh, why do I have... the mountainside. Oh yeah, these looks reasonably healthy. Okay. Fortunately, the damage that's on this board does not seem to have hit the MOSFETs, so I'm happy. There's plenty of other damage up further. No, we don't do better than factory here, we do better than an RF. Oh, come on, Miles. That's not much of a standard. Murta, isn't there someone that you dislike even more now? Isn't the favourite punching bag person someone else today? At least according to Rossman. And I'd love to know what kind of implement they used to create such horrendous scratches. Like I said, I'm guessing it was a what do you call it, a fiberglass pen. And they went to town on that. Either that or it was a metal bristle pen like this. Could have been one of these, as opposed to turning it over and using the hog's hair brush. Because a hog's hair brush won't scratch up the board like that. Give it a blow. And let us compare, see if we do not have a short anymore. $204, I gotta say that's still, yeah, not 100% convinced that's good. Let me see. I'll just check my diode mode values. Okay, according to this, 0.67. Oh, wait, what? What's this 165? Oh. Goddamn people. Who the hell puts in shitty values like this? 1.5. That's not a right value. I'm going to start punching people who put in bad values in open board data. Some people just don't even read the instructions and they just go ahead with their own idea of what they think should be in there. Anyway, I will be doing a revamp of the whole open board data system in the future. 0.17, yeah, see, we should be 0.6, that doesn't feel right, something's wrong. But the trouble is we're now dealing with a higher resistance and I don't know, that's going to be hard to find. This side looks okay. Yeah, 0.156 is it's meant to be 156 ohms probably. So I'll actually correct that for now. 156. Yeah. Okay, so at least that's corrected. PPDC and G3 hot. It could be that they had their range in kilo ohms. That's quite possible. Thanks. Yeah. Oh man, this could be so many things. No, 156 ohms refers to just whatever the value on the network is. It's not a component value. It's a network value. Oh, what the hell? Gotta love these pre-effed with boards. So you... Great. They've knocked off... That's great. SoC S4 PMU 3v3. Okay, so that is supposed to be 0.33 diode mode. I have a feeling this is not going to be 0.33. Ah, well, there you go, I'm wrong, it is. I like it when I'm wrong. Miles, I tend to agree, but as far as I know, this is not a data recovery option one. They just want a working machine. So I feel like it's getting to the point where I'm wasting my time. Like I said, the inherent behavior of these 1706s with their destroyed this left-hand side business, even if you do fix it, 3 weeks later it's going to be dead probably. I mean, look at the amount of corrosion that's been on there. Temperature sensor chip's gone too. You can see the green corrosion just spewing out the sides. So that will cause a high fan spin. Hey Harold. Harold, how goes progress on the USB-C meter? I know you were last working on the ring light. Let's see what happens here. Oh, we got 20 volts. Wow. If this repeats, then it's not finding its mains. I don't know if to trust that or not. It seems like it's behaving. That's kind of weird. I want to have another look at that diode mode value. Hey there, Paul. How? The light ring is almost ready, apart from 3D print. Oh, cool. That'll be good. Be able to start sending people your way. And is the USB-C meter next on the list, is it? Or you're still not sure what you're doing with that? Hey, Sylvia. .14, that's still weird. So switch into resistance mode. If this says 156, then that makes more sense. So there we go. So like we got 170 ohms there. So the 170 ohms matches what's on the open board data, but the whatever the frick it was. Where am I looking? Yeah, the 0.675 seems very wrong. And you know what, to be honest, this is DC in. This is the DC in rail, so it makes no sense that that would be 0.67. I would much sooner rather believe that that is in fact 0.15 or 0.17. That makes more sense to me, given what this rail actually is for. Because this is the rail that all the power comes in. You know, from the USB-C meter. Yeah, it's the primary input rail, so it's not going to have a high diode mode value. It should be low. So I'm going to say that whoever punched that data in, it was probably me, whoever punched that data in got it wrong. So I'm going to say 0.17. By the way, I need to send you the couple of models I have here. I'm sorry about that. I know I've been really slack. I'm a terrible person when it comes to this sort of stuff. Okay, just upload that value. We're done. Alright. So I'm going to throw this into the chassis and see what happens. But yeah, if you look at it from the perspective of what's in the schematic, then it makes no sense that that would be 0.65. I'm just going to go take this outside, brush it out, and I'll be back. Okay, Thomas, thanks for dropping in. Okay. Ooh. I'm going to be very curious to dig back through the database and see who made that entry for that rail. Like I said, a lot of work to be done on open board data. I need to make it that, well, basically at the moment, all the data entries, they are kept separate. So when someone uploads a particular data value, that has a transaction record that is kept. So even though it becomes part of the summarized database, the individual report is there. So that way I can always find out if someone's systematically uploading shitty values and just purge all of their contributions out of the database. Alright, let's see how we go now. That connector feels squishy. Hey, what's happened to my... Oh, well, we've got an Apple logo. For some reason my meters... I did some modifications to the software and obviously I've done wrong. It's booting. What I can't work out with the USB-C meter software at the moment, at least on Linux, is that it's chewing an incredibly high amount of CPU power. It's like 5-6% CPU, even when it's not doing anything. And something very wrong there. It should only be 1% at the most, something like that. And I think it's something to do with the way that I'm writing the text into the textures, which I then upload into the renderer. I must be doing something wrong there, and it's just causing a lot of CPU load. I mean, 5% doesn't sound like a lot, but for a utility like an on-screen meter, it shouldn't be anywhere near that amount. Yeah, I'm going to guess now that it's going to start getting into the high fan spin situation because that TMP416 temperature sensor is not happy. So if we can confirm this boots and everything, we'll shut it down, we'll replace that temperature sensor and see if it behaves better. It doesn't look like it's charging the battery, and if it, yeah, because the battery feels a little bit puffy. Just a smidge. I'm fairly sure it's going to be doing this to me, so I'm going to go get the temperature sensors now. I didn't connect the battery, you're quite right. Yeah. That'll explain that. Whew, why is it hot in here? Well, I'm not going to stop it. I'll just let it finish its startup. Come on. Oh, wow. It's got nothing on it. It's a blank machine. Either that or it's booting into a recovery mode. Okay. Let's replace that TMP chip, TPM or whatever it is. I should have done that before I put it in, but I just wanted to check to see if it was going to operate. Hey, hot flashes, yeah, yeah. Mr. Sensor. Right. There you are. Upside down, you mean you're in the northern hemisphere? Okay, pin 1, top right. Kind of helps if you turn on the hot air. Portugal. Oh, okay. Welcome. Top right. It's a really sad state of affairs, this machine. It's the sort of machine I would expect to see showing up at cash converters. I do occasionally go searching their site, see if I can find any bargains, but they're usually always about 50% more expensive than anything I'm willing to take a shot at. Sometimes I'll consider something simply because of the fact that it may be my only resource for getting a donor board. I'm just going to scratch this up. Yeah, it is very close to wanting a flux and boil, this thing. I do agree. It's extremely close to that level. But that's a lot of different bits and pieces there. Everything has got a bit of tarnish on it. Yeah, Andrew Yale, they've always been a bit expensive, but now some of the prices are getting a bit ludicrous. I've seen some. They need to also put out a memorandum to the stores not to accept machines like A1534s or any other machines that are now on their deathbed lists, like 1708s, 1534s, 1425s. 1932s even, because they're going to end up. I suppose it depends on how they handle it when people come back with a complaint about the machine just died or something like that. I don't know what their warranty support system is like. But they're just asking for trouble taking those kind of machines. Ah, I forgot to put the Wi-Fi on. Oh, Miles, if you're trying to get money out of cash converters, yeah, that's a disaster. You're never going to get any kind of money out of them. Okay, it looks like it's ramping, so it has seen the battery. I was going to say, I did connect the screen. Okay, and as you can see, the progress bar is quite a bit faster now, probably because the battery is connected and also because that temperature sensor chip has been replaced. So I'm not sure if it's in a recovery mode or it's a whole brand new operating system install or what. Guess we'll find out. It's definitely charging okay, 4 amps. Or at least it was. Still taking a while to get through that last segment. See if the fans are going crazy. Fans are behaving, so temperature sensor isn't a problem now. Okay, touch bar works. Okay, yep, now we've got a proper login now, so that's all good. And we're at 1% battery. So we'll shut that down. But in saying that, I will message these people and say, look, it is a 1707. It's got prior damage from a previous repair. I can't guarantee that this is going to last very long. Get your data off and get onto a new machine. Let's see. And just put it over behind me so we can get on to the next job. I just need to go get some water too. It's like 8:30. It won't be long, just got to get some water. There's that other machine. Yeah, you can all get worked up. This one's next. Alright, the problem with this particular one is that someone was doing a battery replacement. Let's see, replacing the laptop battery when attaching the metal retaining clip, dropped it onto the top of the board power connector, and there was a spark and it died. So, tragic accidental death. Get it open, see if we can find anything. It might be something simple. It also might be a total death. Alright, Pedro, that's it. We're going to get you kicked out. Can't have your kind of negativity around here. I'm going to call on my attack dog to get you taken out. Oh wait, that's you. Hey, Repatro. Mr. iPhone. Oops. Wrong hole. Anyway, these things do happen occasionally, so we've all had our occasional hiccups. I'm just happy that they sent it in before trying too much else. Like I said, it could unfortunately be very dead. Really depends on where that landed. Hey, kernels. Alright. Some of these are dead easy to open up. Some of them fool me completely. There we go. Alright, well, dust was a big problem. Let's get this power supply that we used for the short finder out of the way. Yeah, dust is certainly the first big issue that we're going to have to deal with here. Actually, that's not true. No point dealing with it unless we can get it back to life. Okay, see now normally with these connectors, these battery connectors, you don't actually take the metal clip off. It slides back, that's it. So I can see now why the accident occurred, because they must have, at some point they worked out how to get it off, which I don't ever do. Yeah, that's just a slide back connector usually. So somehow they got that out. And that makes complete sense then, that when they tried to get it back on, it went bzzz. The question is, yeah, where did the damage occur? Let's have a look down there. If we're lucky, it just shorted against a cap, cracked a cap or something like that. I'm hoping we can at least see where it sparked. You'd think that, yeah, when these things drop you would see a nice little welding stick mark, but no, you often don't. Let's have a look at the metal itself, see if that shows us any indication. That's pretty bad luck, really. In fact, that's really bad luck. I think I can just see it there on the right corner. But yeah, these are supposed to stay in like this. Just like that. They're just supposed to sit there and not get actually fully extracted. Should just get it over the lip. Would have taken a fair bit of effort to get this out. That one down, that one down, there we go. Yeah. So when you want to extract the battery, you take it back that far and you disconnect the battery. When you want to put the battery back in, you lock it in, you push it forward like that. Okay, well, the battery connector fixed. Let's do some measuring. Yeah, Bazar, I'm actually kind of wondering, it could be that the battery itself fried, shut itself down and whatever. It could have been a polyfuse in there, and the polyfuse has reset itself already now. So I'll just do a quick measurement and then we'll look around. So what have we got here? 580 ground. 580 seems reasonable for this side of the battery. Yeah, I'm willing to give it another shot, to be honest. Yeah, that's good. Because those polyfuses can stay open circuit for quite a while. Hey Jason. I sent you a few more machines today or yesterday? I can't remember. No, yesterday, yeah. Okay, so like that. Plug that in. And then just got to get a plastic attachment. Push it down. What doesn't help here is I don't think this is a genuine, definitely not a genuine battery, and so it's not locking in properly. You can see it's pushing up the plastic up here. That's annoying. Well, that should be locked in enough. B-blood, it's kind of like they've got a bit of a poly wax in them, and then what happens is when it gets hot enough, that wax melts and it no longer becomes conductive. That's the simplest way of putting it. And then when it cools back down, it reforms and becomes conductive again. Battery's got 14 volts in it. Wow, 4-cell battery. Okay. What the hell? The speakers just fell out. No, we don't have power on. Oh, I hate that so much. Do these things have USB-C power? I'm guessing they do not. As in, you can't charge them from USB. So, definitely not. Oh man, what are you? What are you? I think I've got a power brick that should suit this. Nope. Not you. Not you either. Oh, damn it. I thought I had one. What about under here? No, not you either. Oh, blimey hell. Got a billion battery pack charger bricks. Probably not the one I need. I don't think it will work, but I'll try my universal USB one. The one you gave me yesterday. Oh yeah. Forgot about that. There we go. I was gifted this yesterday from Grumpy Tech, who endured coming out all this way into the foreign lands for another job, and was kind enough to pop around for 5 seconds, which is about probably the limit of both of our tolerances of human beings. And there you go. Because I've got no idea if that's charging now, that's all. See if we've got any indicators. Diddly squat. Yeah, definitely nothing showing up. And I can't see any indicators. Well, none of these match. Classic. Hold the power a little longer maybe, alright. Just normally I'd expect to see some kind of indicator that we've got AC in. No, nothing. Right, let's probe around and see if we've got any voltages showing up anywhere. Okay, we've got full 20 volts coming in. Let's see if we're getting any charge activity here. Looks like we're getting charge activity, I think. Yeah, we're slowly going up. Indicators are right below the screen, okay. Anyway, so we are charging the battery. Oh, right, yeah, okay, I got them now, thanks. And none of those are lit, interestingly. These speakers are really ticking me off. So what board are you? It's always fun when you don't have an obvious indication of the board model. Wow, it's not even under there. What's this? DC board. Interesting. I'm not a big fan of daughter boards on machines. What is your purpose? Yeah, I think we'll leave that there. Under the heatsink is probably about right, or it's on the other side of the board. Okay, I guess it's time for exploratory surgery. Unplug BIOS battery. I suppose we can try that. Elastocell. There's not a hell of a lot that can spark and... I don't know. You know what, I'm just going to keep looking. Okay, so we disconnected BIOS. Still got no indications coming up. Yeah, absolutely not a single bit of life anywhere. I'll put a chipmunk on it and see if a chipmunk shows me anything. Actually, we'll do the HDMI port one. Okay, HDMI port shows that we have 5 volts. It's not looking good. We've got no EDRD, and we've only got one data light active. See what... Okay, USB shows us we've got 5 volts power, but again we've got no activity, so we've got a very dead CPU situation at the moment. And we've got no blinking anywhere. So rails are, fundamental rails are there, but not enough. I don't know if we've got 3v3, because we've definitely got 5, and it's stable. We're just going to have to take this thing out. You can get these from Harold CMI Zapper. They're very simple but extraordinarily handy tools. Man, I thought the one that I had the other day was bad enough, but this one is even worse. I really do prefer MacBooks when it comes to this kind of disassembly. As bad as MacBooks are, although I will say the new MacBook Airs are terrible, but as bad as they are, they're usually still reasonable. PC laptops just far too often, I don't know, it's like repairability was even further from their mind than what Apple was. Okay, we've got a grounding. Okay, so the hinges have got to come up so that we can get the board out. That's another design feature I hate. So why do you sandwich the board? Yep. I'm allergic to that kind of BS. Except, Pedro, these are not. These are very expensive machines. And I think that's the part that's even more infuriating. It's like it's not like it's a $500 use for 1 year if you're lucky, cheap student machine. These are serious machines, so far as PCs go. hate doing this so much. You got to play the game of which screws are just onto the logic board, which ones actually go through to the other side. It's like how many of the heatsink screws go all the way through, all that kind of jazz. Okay. Removed. Yeah, very random. Very random. Okay, maybe it's not. It just feels that way. I guess it's so easy to complain when it's your first time around with a board. And then you get all this crap. Okay, I know it's there to protect stuff, but alright, let's have a look, see if we can find anything that's burned. I don't know why I'll bother starting there. Let's see, where's the battery connector? Okay. Well, that's where the battery connector is on the other side. We don't have any apparently burned contacts there. Wow, that's been smooshed. That's not from my work. Chip next to the power jack looks sus. Okay, we'll have a look at that too. But this here looks really sus. Look at that's been just smashed off to the side. Surely I didn't just do that. That's the kind of thing you would feel. No, that's been there for a while. That's not loose. Yeah, it's definitely been there for a while. It's certainly not good. We'll mark that and come back to it, but that's not something I've done. Since this is a red board, I'm going to use a green pen. It shows up a little better than the pink. It looks like it was damaged while it was being installed into the chassis to me. It's going to be easier if I just move the board, not the... I would be looking for some kind of failure on the 3v3 line, the sort of the base line, because the fact we don't even have any of those indicator lights showing up kind of makes me feel like our 3v3 regulator is taking a bad turn. I suppose what we should do is find the board number. There we go. Oh, okay, now I've done some out of factory damage. So this is a GL704GM. GLGM. Schematics. GL704. GM. Well, we've got a GAW. Well, we'll try this one. Ah, someone hasn't mounted their file system. $1940. Okay. Okay, is this it? This does look pretty damn similar. See if we can find that squished transistor for the fun of it. It's above the... It's over here. Somewhere. At the top. I think it might be that one. No, that doesn't feel right. SOT 6. Some bits and pieces. There, it's this one here. P9002. BAV99W. Alright, well, at least we know what that is. It's probably a 2-diode package. This looks close enough at the moment, Miles. So, GL704. What was this? 2.0. So that's the schematic for it. Yeah. Oh, interesting. AC short protection. But anyway, okay, it's close enough for what we're after, so that's good. Okay, so now we want 3v3. Let's see, 3v3 always. Nope. Be easier if I do it this way. Could be that one. Okay, but that's for the RTC battery though. Okay, so 3VA is what we're probably looking for in this case. Oh, this is going to be painful. Question is, who produces it? I love that they don't give us a direction here, so I don't know whether 3VAO is actually the true source or whether 3VA is the true source. This looks like an output, maybe? No. If anybody does know, by the way, just let me know. Oh, that's current limit. OCP. Oh, what do we got? Oh, here we go. Here we go. So 3VAO was in fact probably the true source. What's this? SN51285. What chip are you though? Oh, nice. It's actually a power sequence or power guide. That's handy. SN51285. Let's search for that. What? I can only have one instance of it. Source should be on the... Yeah, right. Yeah. Should be and are, sadly, far too frequently not consistent. None of these chip numbers are showing up here. Okay, let's do it a different way then. AC BATSYS. The EC chip, is it? Okay. So here we have my unusual scenario of not being, what do you call it, accustomed to what I'm working with. What is that EC chip model? Let's see. I'm going to guess the EC chip is up here. This thing here, U3502. Yep. Dennis Pradhomer. Thank you for the Canadian. That is Canadian, isn't it? Canadian $5. Becoming more valuable than US dollars at this rate. Let's see, 3VA. Outputs. Standby 3.3, standby. Okay, so we've got this 3v3 standby. I'm guessing that's what I need to be looking at. And it seems like there's multiple pins of it too. What pin was it? 56. .56 is ground? What? Oh, 57. Hey, MacBook Fixer. Alright, so there's quite a few pins here that are on that. I suppose we should just check to see if we even have that, if we have that standby. Yeah, see how I agree with you that we should have that 3v3 on the power button. Like I said, that's why I'm worried, because normally you'd expect that if nothing else. So this here is where our 3v3 should or could be. We're going to plug in the power. I'm fairly sure that should work. And if it doesn't, we'll complain to the person who gave us the power brick. Yeah, without the battery. Oh, what's the board concern? I don't know, because I do not have it on USB-C power connector. Unfortunately, it seems like my array of connectors doesn't include this one. Okay, we definitely do not have 3v3 standby. Let's see if we've got any power going into the EC chip. Okay, what do we got? Okay, so that means we have to bring out the oscilloscope. Not sure I'm willing to do that. V-source, that's ground anyway. That's what V-sources are, because we're talking in terms of MOSFET terminology, so source is actually what we call ground. V-core, I'm going to guess V-core is it. I don't really appreciate the fact that the font offsets are a little bit weird. Actually, seriously though, where is the main power input? Check first and second MOSFET. Well, we are getting power through because the whole thing's charging, so we're definitely getting through the typical, reverse polarity protection, surge protection section, and it is charging the battery. We're just not getting the EC's not coming up. The 3v3 LDO supplied. Yeah. Now, the question is, where is that? Oh, okay, so for it to charge, it actually has to have a living EC. Alright. I wasn't aware of that one. Check the other cap around the EC. Right. Okay, so basically you're saying, look for the big fat caps that are around and have a spot of luck, if you may. It's standard, what is this, Soren technique? That's actually not too many. Okay, so this one here is the dead one, so that's 0 for all intents and purposes. There's actually not much around here. 0.15. I'm picking those ones because they had fairly chunky feed lines into them. The CPU's getting warm, I'll tell you that much right now. Actually, it's not the CPU. No, it's something else. Oh, or is it? PCH, I think it is. No. This over here is getting warm. We're getting hot over here. Is it possible that wasn't the EC I was looking at? No, it was. It had all the button controls on it. So what's this then? Yeah, what is that chip? Now I've still got to find this warmth. Where are you coming from, buddy? Oh no, yeah, it is either the CPU or the GPU getting warm. Yeah, CPU or GPU are getting warm. How can they be getting warm? There's a lot of flux around there. Why is there flux around there? That's and obviously I haven't put flux there, but there's definitely flux. Flux, flux, flux. But that's factory. I feel like there's flux from under the PCH. But the question is it factory? No, we're all down here too. Hey user. Yeah, somebody's reflowed. I agree. Because that's the solution to everything. Oh wow, well, yeah, we've got more flux heavy. Actually, no, I don't think that one's flux. I think this is that stuff. That is from the thermal transfer pads with your SSDs. So okay, that's okay. That's not flux. But the run around the PCH, that definitely looked like flux. Let's have a look at this PCH edge on. See if we can tell a different story. They may not have got it up to reflow temperature. It may have just been a case of, you know, they heat it up, but it doesn't actually get to reflow level. Kind of like what you do with the old AMD GPUs. I'd just love to know where it's shorted. If I had to guess, it probably would have shorted down here on this, what is this? U6509 or whatever this one is here, this 1285A. Look, that would be my guess on what it could have shorted on. So I suppose it wouldn't harm to have a look and see what that circuitry does. Unfortunately, I can't tell what it does current-wise because this is not going through USB-C charge. So yeah, I'll have a look at see what this circuit does, because if I, like I said, if I had to take a guess when they were trying to push this metal bracket in, they would have had to come in from this angle and the battery would have been locked, you know, in place, and so something like that there could have shorted. Yeah, it's a bunch of possibles. So I'm pretty sure this is PJ6003. It is. Yep, we've got our big caps here. Okay, that's part of the battery con. What's this do? Hey Jason. Hey Nuts and Proud. So this is the small square chip that's next to it, and what does it control? 3 volt always and 5 volt sus. Okay, so this is like an ISL 7000 type thing. So, oh, thank you, laptop. Well, yeah. Let's see. Okay, so this here, right, this is what I was looking for all along. It was right there in front of me, 8703. If it doesn't have SM clock, nothing will be happening. Okay. Where the hell's the inductor on that one? It's not on the other side. Oh wow, big chunky one down the... Okay. Alright, let's plug it in and see what else it can do. Still, I would expect that to be running because again, like I said, we've got heat coming out of the CPU or the GPU. We've got heat coming out somewhere. It's very strange. Yeah, 5 volt. So I would check the 3 volt section. Anyway, let's just have a sniff around here. Okay, 5 should be the 3. We've got 3.3 there. So they seem to be alive. I guess this is the 5. Yep. And this might be the 3. Yep. Okay, so we're definitely getting those voltages out there. So where do they stop? Let's try on the other side of that polyfuse. Actually not polyfuse, it's a shunt. Okay, 20 volts. What? Oh, right, whoops. Yeah, my bad. That's what makes you think you don't have SM bus, everything else will get power, nothing will start. But would the CPU and PCH not even start? Okay, let's have a look for the SM bus. Any particular one you're thinking of? The BIOS battery is unplugged, yeah. But it wasn't a problem. I mean, it wasn't working prior anyway. Okay, how about we go SMB clock? So you're on top side here, just on the other side of the PC. Ah, you're under a BGA. Where are you on the underside? Oh, you're not an easy sucker to find. Okay. It's very annoying when you don't have proper board outlines. Let's see if I can find that. So we've got a SOT 23, we've got a... yeah. I think I know where I'm heading. Wow, my camera is way out of alignment with the camera, with the head. I'm just going to have to turn my camera around slightly, folks. I've just noticed it's drifted away from true. AU hex drivers. Oh gee, not even close. Maybe a T8. Nope. So we want T10. So he grabs another T8. Oh, that's beautiful. T8. Well, it looks like T8 doesn't do it either. I mean, sorry, T10. T15 looks a bit too big. Except it's not. It's perfect. Okay, it's hopefully better now. Yep, that's better. Alright, yeah, this is definitely the region that I'm looking for. And what am I looking for now? Oh, we're looking for the clock, that's right. And the clock is this one here. And we've got 3.3. Well, that's SMB clock is 3.3. Now, do you really want me to bring out the scope for that sucker? Because it seems like that's up and running. Stuck high sounds about more right, yes. I agree. I was just looking at the schematic here, and that makes more sense. Oops. Because it is running at 3 volts, so therefore something's not pulling it down to do the normal clocking, so yeah. So if we probe that right now with the scope, we're just going to see it's stuck constant. So yeah, we're not getting that clocking. Brilliant. And the question is, where does that even damn well come from now? Oh, that comes out of the PCH. So what we're essentially saying is that PCH is DED. Would that be about right? Especially for the fact you combine that with the reflow flux. I think we can say that this has killed the PCH. At least that would be my summary at this point if I was forced to have to give one. What's your view? Do you think that... Yeah, Miles, I know you did, but you know, I've got to run these through properly. Yeah, I can't just sort of say, oh yeah, it's PCH. Particularly when I'm not even... And besides, it's a learning experience for me too. But annoying. But yeah, so we've got these resistor bank networks. Theoretically, if we got another PCH, would this be worth repairing? So how many we got in here? 874 pins. It's not so bad. I don't know what CPU gen this one is, sorry. Can't answer that question for you. All I've got is maybe this. Yeah. Oh well. we tried. At least we had one kind of win tonight with the 1707. Check the 8th pin of the BIOS chip's resistance to ground. Gee whiz. Okay. Which one's the BIOS chip? Okay, easy way to find out. We just look for BIOS write protect. And when you say the 8th pin, you mean legit pin 8, like that one there, which is, what do we got? 3V1VA SPI. Okay, let's have a look at that. Sometimes you go looking for the BIOS chip and forget that it's a massive thing compared to everything else. Let's see. Resistance to ground you want. Okay, resistance mode pulled up. There you go, about, call it 420 ohms. No, it's a MXIC MX chip, but that looks factory. That doesn't look like that's been changed. So yeah, 425 ohms, 450 if you want to round up. Well, that's it for tonight for me. As I said, we've got one partial repair. Like I said, I'm going to have to discuss matters about that 1707 with the owner and give him fair warning. It's probably not ideal either way. But yeah, maybe they do want it for data, in which case then that's fine. They should be able to get data off that and then throw it in the dumpster, unfortunately. It's just the way it is. Yeah, the 1708s were a very nice machine, but definitely they're getting a bit old now. In fact, they're sort of aging worse than 1502s and 1466s, it seems. Just, I think it's the way they designed the air transfer, and which is, of course, as we know, a problem that carries through to the 1990 and the 2141. But, oh well, it's the way it goes. Anyway, thank you all. I appreciate you all being here. Thank you very much for helping me try and track down, get to the legitimate cause of this fault here, or the actual fault here. Sorry if it was a bit irritating for you to watch me slowly get to where you said I was going to end up. But like I said, sometimes you just have to go through these things, and then at least I can do a write-up and confidently say this is what appears to be the problem. So I'll see you on the next stream, whenever that may be. And then until then, you take care. Thanks again. I'll catch you later.